Today we're solving systems of linear equations, but by a method called substitution. So when we're using substitution, our first step is going to be to solve one of the equations for one of the variables. I need to make one of my equations start with y equals or x equals. Then I'm going to substitute the expression that I just got in step 1 into the other equation and solve for my variable. Once I've solved for one variable, I'm going to substitute the value from step 2 into my original equations and solve. So let's try an example. So here I already have one of my equations set up as y equals negative 2x minus 9. So step 1 is basically already done for us. So we're on to step 2. I'm going to take my second equation, 6x minus 5y equals negative 19. And in place of the y, I'm going to put negative 2x minus 9. So 6x minus 5 times negative 2x minus 9, and it should equal negative 19. So I'm going to simplify here. Add the opposite, and distribute my negative 5. So negative 5 times negative 2x gives me 10x, and negative 5 times negative 9 gives me 45. 6x and 10x gives me 16x, and I'm just going to continue solving for x here. So I'm going to subtract 45 from each side, and I get 16x equals negative 64, and divide each side by 16, which gives me x equals negative 4. Now, once I have solved for one of these variables, I'm going to take this answer and substitute it back into my original equation to find the value of y. So I had y equals negative 2x minus 9, or y equals negative 2. Instead of x, I'm going to put in negative 4 minus 9. So I get 8 minus 9, or y equals negative 1. So now I've solved for both my x and y. So I have my solution. Negative 4, comma, negative 1. But I always want to take that solution and test it out in my equations and make sure it actually works. I've already tested it out here because I plugged in negative 4 for x and I got a value of negative 1 for y, but I want to definitely test this point out with this equation right here. So let's do that. So 6 times x, we'll put in negative 4 for x, minus 5 times y, we're putting in negative 1 for y, and we want an answer of negative 19. So I get negative 24 minus negative 5 equals negative 19. This is the same as saying negative 24 plus 5. And that does in fact give us negative 19. So our solution checks out. So negative 4 comma negative 1 is our solution for this system of linear equations. Let's take a look at another example. This time, we do have to start with step 1. Neither of our equations are set up as x equals or y equals, but I'm going to take this first equation and make it y equals by adding an x to each side. So I start off like this. I'm going to add an x to each side. My minus x and plus x cancel out, and I'm left with y equals x plus 3. So I'm going to go on to my second equation. 3x plus y equals negative 1. And in place of the x, I'm going to write in x plus 3. Sorry, in place of the y, I'm going to put in x plus 3. So here I'm not distributing anything but a positive 1. That's not going to change anything. So I'll have 3x plus 3 equals negative 1. Or 4x plus 3 equals negative 1, and I'm just going to continue solving for x here. And I finally get that x equals -1. Now I'm going to take this answer and plug it back into this equation to solve for y. So we had y equals x plus 3. So y equals -1 plus 3. This gives me an answer of 2. So for my ordered pair, my solution, I have -1, 2. Now I want to test this solution by plugging it back into my original equations and making sure that it works. So let's first test it in our first equation. We'd have negative, and then for x we're putting in -1 plus 2 equals 3. Well, this double negative just becomes 1 plus 2, which does in fact equal 3, so it checks out with our first equation. Now let's test it with our second equation. 3x, or 3 times -1, plus 2 equals -1. So we get -3 plus 2, which does in fact equal -1. So our answer checks out with both equations. So -1, 2 is our solution for this system of linear equations. All right, let's look at a real-life example. So here we have a drama club, which has earned $1,040 from their production. 64 adult tickets and 132 student tickets were sold. Adult tickets cost twice as much as student tickets. They want a system of linear equations that represents the situation. And then we want to find the price of each type of ticket. So from all the information given here, we need to write 2 equations. So we're trying to find the price of an adult ticket and the price of a student ticket. So the first thing I'm going to do is assign variables to those 2 things I need to find. So x is going to be my price for an adult ticket, and y is going to be my price of a student ticket. So I know that they sold 64 adult tickets, so 64 times whatever price those cost, and 132 student tickets, and that added up to a grand total of $1,040. So there is one equation I can write. They also told me that an adult ticket costs twice as much as a student ticket. So an adult ticket is the equivalent of 2 student tickets. So there's a second equation I can write. So this one's already set up, x equals, so when I go to solve here, in place of x, I'm going to put in 2y. So 64 times 2y, I get 128y plus 132y equals 1,040. So all together here, I have a grand total of 260y equals 1,040. I'm going to solve for y by dividing each side by 260. And for y, I get a value of 4. So y is the price of a student ticket. So a student ticket is $4. Now, if I take this y equals 4 and substitute it into my second equation, I can find the price of an adult ticket. So 4 goes in place of my y, x equals 8. So $8 is the price of an adult ticket.